This is the summary created from the video. Lecture 51 Do Computing. The demand for renewable, carbon-free generation is increasing as per capita energy consumption rises, necessitating the efficient management of energy through smart grids and DC microgrids. DC microgrids consist of various components like DC loads, generations, and storage systems, with control schemes involving battery, ultracapacitor, grid-side converter, and photovoltaic source in loops. A comprehensive power flow control strategy manages the energy flow between the grid, solar photovoltaics, battery, and loads based on different scenarios, prioritizing the supply to the grid during peak hours if excess PV generation is available after charging the battery. The simulation setup consists of a grid interactive DC microgrid implemented in a real-time simulator, with components like PV modules, battery, ultracapacitors, DC link load filter, and utility grid and control parameters chosen for each component. During peak hours, the energy management considers factors like PV output versus load and battery state of charge, with different cases explored based on the relationship between PV output load and battery SOC. In off-peak hour mode, the bus voltage is maintained close to 48 V, with minor variations observed in power voltage and battery currents, and different cases considered based on the relationship between PV output load and battery SOC. In isolated mode, the energy management scenario employs smooth control strategies for balancing available energy, handling both grid-connected and isolated modes efficiently, based on the state of charge of the battery and the relationship between PV output and load. The simulation results demonstrate the successful implementation of the proposed energy management strategies, achieving reliable and efficient microgrid operation by optimally utilizing photovoltaics and storage under various grid conditions. The key takeaways include optimizing energy usage through demand response and DC microgrids, integrating renewable sources and storage into smart grids, implementing control strategies to manage energy flow based on scenarios, simulating real-time scenarios across grid modes and conditions, and achieving reliable, efficient microgrid operation with photovoltaics and storage, providing strategies for renewable utilization up to 30%. Please stay tuned for more summary videos.